Welcome to this video where we're going to take a look at an example of an optimization problem using linear inequalities. This is going to be a bit of a longer video as I'm going to go step by step on how to solve this question, taking a look at all the nuances of a optimization problem and then working on how to solve. So let's read through this problem first in the example that we have. Now we have a manufacturer that makes long sleeve and short sleeve t-shirts. We know that each long sleeve shirt requires 4 minutes on the cutting machine and 3 minutes on the stitching machine. Okay? Each short sleeve shirt requires 3 minutes on the cutting machine and 1 minute on the stitching machine. The cutting machine is only available for 2 hours each day, and the stitching machine is only available for 1 hour each day. So you're hearing parameters that are coming in that we're going to have to look at a little bit later. Then, if the profit on a long sleeve is $5.20 and $3.80 on a short sleeve, how many of each should be produced each day to maximize profits? Now, you've heard that word, maximize profits. So what we're looking for is we want to optimize this procedure here and figure out how many long sleeve t-shirts we want to make and how many short sleeve t-shirts we need to make in order to get the highest amount of profit. Okay, biggest amount of profit. That's what we're looking for right now. So first thing we need to do is figure out what we're trying to optimize, and that is our profits. Okay, so we're going to start with that. First step that we're going to take a look at is we need to define the variables. Okay, and we're going to have two variables. Our two unknowns, the things that are going to affect our maximum profit or affect our profits, are going to be how many long sleeve shirts were made and how many short sleeve shirts are made. Now, if you want to switch these around for the x and y, that is fine. But when we define our variables, we are determining what value is going to be x is going to be and what value y is going to be, so that when we do different calculations to them, we're understood that is our those are our variables. All right. Second thing, we're going to look at what is our target equation, or what is our equation that's going to go with our maximizing. Okay, and I'm going to call it a target equation in this case. So you might hear some other words. I've sometimes used other words as well, but we're going to call it our target equation right now. All right, what we're trying to maximize is our profit. And this is what it looks like. The profit is equal to $5.20 times the number of long sleeve shirts plus $3.80 times the number of short sleeve shirts. This is how we're going to determine what our profit is. If we sell if we make 0 shirts, we have a $0 profit. As you're adding long sleeve shirts and short sleeve shirts into this mix, you're going to have a bigger and bigger and bigger and bigger profit. We want to figure out, based on the parameters, what is the greatest profit we can make. All right, let's put the target equation aside for the time being. Let's look at what are the parameters that we have. What are the inequalities we have? This is the parameters. All right, first parameter that we're going to look at is the cutting machine. If you look at the cutting machine there, it is available for 2 hours or 120 minutes each day. We know that for every long sleeve shirt we want to make, it's going to take 4 minutes. For every short sleeve shirt we're going to make, it's going to take 3 minutes. So to figure out the parameter on there, we're going to take 4 times x, which is our number of long sleeve shirts, plus 3 times y, which is our short sleeve shirts, and that has to be less than or equal to 120. We don't have to use it for the whole 120 minutes, but we can use it up to and including that 120 minutes. So there's our parameter on the cutting machine. Now that you have that one, you can probably see what the parameter on the stitching machine is going to be. That one only has 60 minutes of time. And in there, we are going to do 3 times the number of long sleeve shirts and 1 times the number of short sleeve shirts. You don't need the 1. But that has to be less than or equal to 60 because it's only available for 60 minutes each day. Now, there are a couple of extra ones that I'm going to plug in just for the sake of showing where this ends up. But we know that x has to be greater than or equal to 0, so we can't have less than 0 shirts. And y on the same side has to be greater than or equal to 0 as well. And that's going to come into play when we look at graphing this out. So there's our parameters. We have 4. Okay, and so we're going to graph those out on a graph. So let's graph out the inequalities, not the target equation, just the inequalities. All right, they look like this. All right, we now have 4 points that surround an area that is not really a triangle or square or rectangle, but it's a four-sided shape. We have the points 0, 0, 0, 40, 12, 24, and 20, 0. So these points right here represent our max and min points, and maybe a couple others as well. The 0, 40 represents 0 long sleeve shirts and 40 short sleeve shirts, which would work based on our parameters on the stitching and cutting machine. The 12, 24 is 12 long sleeve and 24 short sleeve, and the 20, 0 is 20 long sleeves and 0 short sleeve shirts based on the definition we did for our variables. Now, which points are maximums or potential maximums? Well, is 0, 0? No, it's 0, 0 is definitely not. That's going to be your minimum. That's going to be a minimum profit of nothing. So these are our three pieces right here. Okay, and like I mentioned, 0, 0, not going to be a maximum. Those three have the potential to be a maximum. So what we want to do now is we want to determine what is the profit based on each one of these pieces. And so that is our next step here. We're going to check the maximum values or the maximum profit based on our target equation, and that's where we're bringing our target equation back into play. So our first point there is 0, 40. 0 long sleeve, 40 short sleeve. If we put that into our profit formula, we're going to get a profit of $152. Okay, that's going to be our profit for the day. If we put 12.24 in, we're going to get a profit of $153.60. Okay, so it's a little bit more. So we can now kind of get rid of that 0.40, so to speak, and we know that 12.24 is in fact more than that. Now, our last one, 20.0, so 20 long sleeve and 0 short sleeve, is only going to give us a profit of $104, which is way less than either of the others. So in other words, our maximum is going to be this one right here. All right, so that's going to be our maximum. Now, what do we do at the end? Once we know our maximum, we need to explain our answer. So don't just say 12.24. Because when it's all said and done, we have no idea what the 12 represents or the 24 represents if we haven't looked back at your work. So give a statement that represents what the maximum is. So here is my statement, and it says a maximum profit of $153.60, so what is the maximum, will be produced if 12 long sleeve and 24 short sleeve shirts are made. It makes it concise, simple, put all together, so now we know what the maximum is and how are we going to achieve that maximum. That is the end of the question. I hope that has helped you. Thank you for watching, and all the best as you work through your questions.